Is there life on Mars? It's an age-old question made famous by David Bowie, but pondered by many great minds over the years. There's no definitive answer yet, but probably not would be the most likely conclusion. In my mind, there's an even more fascinating question that dips back into the ancient past of our solar system. Was there life on Mars? There was a time when the red planet looked a lot more like the Earth and supported many of the same functions of nature that we rely on for our own survival, including oceans and rivers of liquid water. Could Martian life have evolved the same way as life on Earth, and if it did, then what happened? It wasn't that long ago that some people on Earth actually believed that Mars was a fertile planet that supported life and a civilized society evolving alongside our own. The canals of Mars was a popular theory around the turn of the 20th century. Using the telescopes that were available at the time, some astronomers believed that they could detect linear channels along the surface of Mars, marking bands of vegetation that were kilometers wide, bordering irrigation ditches or canals dug by intelligent beings to carry water from the polar caps. This was not a widely adopted conclusion, and in fact they were just seeing optical illusions caused by the chance alignment of craters and other natural features on the surface. Canals of Mars was basically what we would label a conspiracy theory in today's terms, but it does illustrate humanity's fascination with life on the red planet. The Mars of today is well known to us. It is a frozen, lifeless desert landscape with no activity beyond the occasional dust storm. But it was not always like this. To find the golden era of life on Mars, we would have to go deep into the planet's ancient history, 4 billion years ago. At this time, the surface of Mars would have looked very similar to the surface of the Earth. They would have passed for twins, each covered by a rocky landscape under cloudy blue skies, and both containing vast oceans of liquid water. The period on Mars from 4.1 billion to 3.5 billion years ago is typically thought of as the age where the planet would have been habitable for life, although it could have lasted to as long as 3 billion years ago. The key ingredient here is the presence of liquid water. Mars would have had a global network of oceans, rivers, glaciers, and lakes with significant amounts of rain falling near the equator, which we can see in the presence of valley networks, features formed by erosion from flowing water. On the Earth, water is the solvent of life. It is capable of dissolving more substances than any other liquid. We, as living beings, are essentially just a massive collection of minerals and molecules suspended in water. Everywhere on Earth that we find liquid water, we find life in some form, no matter how hot or how cold. Life always finds a way as long as there is water available. The first water appeared on Earth 4.4 billion years ago, and the first evidence of microbial life dates back 3.7 billion years. So on the cosmic timescale, it does not take very long for life to emerge in the proper conditions. Life as we know it, that is, but let's not go there quite yet. The climate of Mars 3 to 4 billion years ago is a bit tricky to determine. The Martian surface features do not seem to fully support either warm and wet or a cold and dry climate during that time. Scientists are currently leaning towards the idea that Mars was both cold and wet, maybe a bit like northwestern Europe in the winter. An ocean would have formed in the northern lowland basin where the atmosphere was denser and more warm. Water would evaporate from this ocean and return to the surface as rain or snow. In and near the ocean, it would be mainly rain, but in the southern highlands, where the air was cold, it would be mostly snow. The snow would accumulate into extensive glaciers, which would flow down to the lowland basin, returning the water to the ocean. At the time, Mars would have had an atmosphere as thick as the Earth to maintain heat and pressure on the surface, made primarily of carbon dioxide with about 10% hydrogen, a highly efficient greenhouse gas. The unfortunate reality of Mars is that the planet's era of liquid water was cut brutally short. As the climate of the Earth became more and more hospitable for life, the surface of Mars became more and more hostile to life. Mars is a much smaller planet than the Earth with significantly less mass. If Mars ever had a hot, energetic ball of metal at its core, the same as the Earth, it would not have had enough mass to maintain that powerful activity. As the planet's core cools and solidifies, the magnetic field generated by it would dissipate. This loss of magnetism would leave the planet vulnerable to the erosion of the solar wind. Stray energized particles ejected by the sun impact the planets and moons. Without a magnetic shield to deflect this energy, it will simply blow away any gases above the surface, carrying them off into deep space. Regardless of how it happened, we know that the atmosphere of Mars was slowly stripped away over eons of time. This loss of density would have reduced the atmospheric pressure, and as pressure drops, so does the boiling point of water. The reason an Instant Pot can cook food so quickly without drying it out is because of the increased pressure inside the machine. This increases the boiling point of water, allowing food to get hotter without evaporating its moisture. Mars is like a reverse Instant Pot. The pressure dipped so low that any water above the freezing point would simply evaporate. So it is now physically impossible for liquid water to exist on the surface of Mars. The only water left on the planet was frozen. This is mostly found in polar ice caps, but there is also subterranean water ice under a lot of the Martian surface. So what are we trying to say here? Mars absolutely did harbor the conditions and the elements necessary for life as we know it to develop, and the planet maintained those conditions for a long enough time that would allow primitive microbial life forms to develop, based on what we know from the Earth, that is, but we can assume that the same would be true for Mars. Occam's razor, the most simple explanation, is likely the most true, so it stands to reason that the same processes that occurred on Earth would have occurred similarly on any similar planet. Unfortunately, while the Earth would go on to spend billions of years serving as an incubator for life and evolution, Mars would simply become a hostile wasteland, and the window of opportunity for Martian life would close. However, there is still a lot that we don't know about the planet Mars. Could there be a possibility that the window for habitation has remained open, even just a tiny crack? As recently as September 2022, we've seen new research published that would suggest liquid water still remains on Mars. According to researchers at the University of Cambridge, there is evidence that would suggest Mars still contains liquid water under the frozen surface of its polar ice caps. They've come to that conclusion by monitoring the patterns of the ice caps' change in height through the Martian seasons, noticing that the altitude of the frozen peaks would rise and fall in undulating patterns, suggesting that they are actually floating and not frozen all the way through to the rocky surface. Professor Neil Arnold from Cambridge's Scott Polar Research Institute, who led this research, told the Journal of Nature Astronomy, "The combination of the new topographic evidence, our computer model results, and the radar data make it much more likely that at least one area of subglacial liquid water exists on Mars today, and that Mars must still be geothermally active in order to keep the water beneath the ice cap liquid." That would sound far-fetched, but again, we look no further than the Earth to find a similar process at work. Lake Vostok is buried 3.7 kilometers beneath the frozen surface of Antarctica. Water in this circumstance would ordinarily be too cold to stay liquid, but the abnormally high salt content of the lake keeps it from freezing. Vostok is also known to be teeming with life. We've confirmed thousands of microbial organisms living in the brine, but it's believed that the lake could even support fish. If we stick to our theory that processes we see on the Earth will occur similarly on similar planets, then Mars could have its very own Lake Vostok, and the same could even be said for ice-covered seas on worlds in the deeper solar system such as Europa and Enceladus. The problem that we face here is that it will be spectacularly difficult to find and confirm the evidence of this primitive life on alien worlds. It took us until 2017 to prove the existence of microscopic bacteria preserved in 3.5 billion-year-old rock from Western Australia. It had been theorized for decades but required the use of a secondary ion mass spectrometer a device of which there are only a handful in the world, to separate the carbon composing each fossil into its constituent isotopes and measure their ratios. Different organic substances, whether in rock, microbe, or animal, contain characteristic ratios of their stable carbon isotopes. It took a decade to develop this process, and it finally revealed microfossils that are so incredibly small you could stack 8 of them along the width of a human hair. So what we essentially have to do to prove alien life is to visit these planets and moons, then find a needle in a haystack while blindfolded, then get it back to the Earth and develop a process to analyze and understand what we've found. This one is a daunting task ahead of us, but until then, we've only got our theories and assumptions to go with, but it's still pretty fun.